Good morning, students. Good morning, Jitesh sir.
Good
On
morning,
behalf, yes, sir. Good morning. On behalf of Kusrabadia Institute of Technology, I, Shubhangi Kishan Verma, Faculty Advisor of IEI and ISTE CWIT Student Chapter, welcome you all for second day of this IoT and its application workshop. So everybody pay attention and give your best during the session. And Jitesh sir is giving a wonderful session. Yesterday you have attended, you have seen, you have interact with him. So I request you all today also give your best. And if you have any question, you can ask. But before asking the question, take permission from Jitesh sir. Aryan, please turn off your camera, Aryan. Your camera is on. Thank you. And whenever you want to ask question, that time students, you can unmute your device and otherwise keep your device on mute. Is that clear, students?
Yes,
Am I
ma'am.
clear, students? Unmute your device and tell me.
Yes, ma'am.
Yes, ma'am.
Thank you.
Yes, ma'am.
So now I request Jitesh sir to start with the day 2 session.
Oh, okay, ma'am. So screen visible, ma'am?
Yes, sir, it's visible, sir.
Okay. So good morning, everyone. So today, this is the day 2, session 1. So in this session, we will understand about the introduction to Arduino, and there are a lot of Arduino board in the market. So we will study about the Arduino UNO and also the Arduino IDE and analog to digital converter that are part of the Arduino. And also we also do one thing, small hands-on also, that is a TMP36 sensor interfacing with Arduino. For this sensor, you no need any hardware, so we will do this hands-on onto the simulator. So introduction to Arduino. So what is a Arduino? Arduino is a microcontroller board, contains onboard power supply. There is a USB port to communicate with the PC and also the Atmega microcontroller chip. So it simplifies the process of creating any control system by providing the standard board that can be programmed and connected to the system without need of sophisticated PCB design and implementation. Means there is no a big PCB required. So it is a open source hardware at any, and anyone can get this detail of design and modify it and make it on himself. So everyone, if you are logging through your laptop, so please open the Google, and on the Google please write arduino.cc. This is the Arduino website. So everyone open the Google and write here Arduino website is arduino.cc. So this is the website. Everyone please open this website. I will share the link of this also with you. The link is shared. Please open that link. So in this is the Arduino official website. So we have to click on this, what is Arduino, on left hand side. Everyone just click over there and click here, learn more about Arduino. Everyone, and open this page. So what is Arduino? So Arduino is a open source electronics platform. Open source means the hardware details and the software details are free. You can use it, no need to pay anything. So Arduino is an open source electronics platform based on easy to use hardware and software. When you want to use hardware and software easily, that time you can use it. Arduino boards, there are a lot of Arduino board in the market. If you open it, so Arduino boards are able to read input. Means there is a light on the sensor, there is a finger on a button or a Twitter message. So they can read input and turn it into a output. What output means? Like activating a motor, turning on the LED and publishing something online. So you can tell your board what to do by sending a set of instructions. So we will learn how to write these instructions to the microcontroller on the board. So we have to send a set of instructions to the microcontroller on every board. So to do so, we have to use Arduino programming language and also the Arduino software, and based on processing, we have to use Arduino IDE also. So see here everyone, there are a lot of board in the market. So based on the full range of Arduino products, there are some hardware are called boards, some hardware are called modules, some hardware are called shields, and some hardware are called kits. So browse the full range of the official Arduino product, including board, modules, shields, and kits. So there are 4 categories: board, module, shield, and kits. So there are some boards that are entry level. If you are beginner, then you can start from these boards. So get started with Arduino using entry level products, easy to use and ready to power your first creative project. So there are a lot of boards: Arduino UNO, Arduino Nano, Arduino Micro. These are the Arduino Nano Every, Arduino Leonardo. These are the entry level boards. And the second is there are some boards which has enhanced feature. This is Arduino Nano 33 BLE, Arduino Nano 33 BLE Sense. These are some advanced feature boards. Arduino Mega, Arduino DUE. These are some advanced feature boards. And there are some boards that are related to IoT. These are the boards. Arduino and Nano 33 IoT. These are the Arduino board that are related to IoT. And there are some educational kit from the Arduino. And these are some retired boards. These are some Arduino 101, Arduino Ethernet. These are some retired boards. Okay. So means they are some older boards. See here, there are some older boards also in the market. These are the categories of older boards in the Arduino. So these are some Arduino older boards. See here. So right now we will work on Arduino UNO. The first one, that is the Arduino UNO. We will understand this is the entry level because this is the most used and robust board from the Arduino category. So Arduino UNO means one in the Italian, because this is an Italian company. So UNO means one. So Arduino UNO is the best board to get started with electronics and tinkering with coding. If it is your first experience tinkering with the platform, UNO is the most robust board. You can start playing it. And this is the Arduino UNO board. This board we will use. So see here, everyone. These are some different board: Arduino UNO, Mega, Arduino Nano, Arduino Mini, Arduino Lilipad, Arduino BT. These are some Arduino's board. So we will talk about Arduino UNO. So in this Arduino UNO, there are the pin. These are the numbering of the pin that are written onto the board. So pin number 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 13. So there are total 14 pins. It is started from 0 to 13. Total 14 pins that are for the digital input output. These pins are for digital input or digital output, and there are some pins that are with tilde symbol that are for the PWM pin. So pin number 3, 5, 6, 9, 10, 11, these are the PWM pins. So these are some 14 digital pins. Out of 14, 6 pins are the PWM pins. And there are 6 analog pins. A0 to A5, there are 6 analog pins. This is the microcontroller onto the board, Atmega 328P. In this, there is a microcontroller, Atmega 328P, and there is some power supply pins. Near to the analog pin, there are some there are 2 ground, V in, 3.3 volt, 5 volt. These are some power. And this is the, you can power it with USB, you can power it with AC to DC adapter. So this is the Arduino UNO specification. So all the details you can get here also. See in the Arduino website. Everyone just open this website. Open this web page. I will share the link of this web page. Is there any doubt till now? Is there any doubt
No,
till
sir.
now? So
No,
how
sir.
many you already worked onto this Arduino? How many students already work onto the Arduino? Yes. How many students you already worked onto the Arduino? Do you know something about the Arduino? You know anyone? Anyone? You can speak by unmuting your mic. Anyone? Yes. Do you have any idea about the Arduino? You know?
Yes, sir. Some students have already done projects on Arduino. Yes, Gaurav Chaisingani is there.
Yes,
Then
ma'am. Yes, ma'am.
Mayur Raikar is there. There are more 2-3 groups are there. Then Shreya, you are also working on Arduino. You should speak up, students. The session should be interactive. Then only
Please, everyone, speak.
speak up.
You have to communicate with me. That would be helpful for you and make the session interactive. This is not college class. I cannot cut your marks. Don't worry, just enjoy the session. If you have any doubt, so freely you can ask. So this is the Arduino UNO board, and this is some details. Arduino UNO is a microcontroller board based on Atmega 328P. So there is a microcontroller, and this is the name of the microcontroller, Atmega 328P. So there are a lot of board in the market. Arduino UNO, Arduino Nano, Mini. So you have to choose according to your application. So it has 14 digital input-output pins, out of which 6 can be used PWM. There are 6 analog pins, and there is a 16 megahertz ceramic resonator. And there is a USB connection, a power jack, and a ICST header, and a reset button. So this is, see here, this is ICST header in system, in circuit system programming, and this is 16 megahertz crystal resonator, and this is USB to UART bridge IC. So, and there is a reset button. It contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable or power it with AC to DC adapter or battery to get started. You can tinker your Arduino, without worrying too much about do something. Worst case scenario, you can replace. So there is no big issue. You can use like any in any manner. So Atmega 328, there is a replaceable chip, and there is also 1 KB of EEPROM memory, and there is also the battery connector. These are some technical specifications. See here, Arduino UNO. This is the board, and this is the Atmega 328P USB B connector. There are at pin number 13. There is a built-in LED at pin number 13, and there are 14 digital pins. Analog input are 6. PWM pins are 6. Yes, there are UART functionality. I2C, SPI input-output voltage. It is 5-volt tolerant board. You can do input voltage between 7 to 12. DC current per input-output 20 milliampere you will get. Power supply you can use barrel plug. Main processor is Atmega 328 that work on 16 megahertz, and a USB serial processor Atmega 16U2 that is 16 megahertz. So in Atmega 328 there are 2 KB RAM, 32 KB flash, and 1 KB EEPROM. Please these are the some details you have to understand. So now this is the all details. 14 digital input output, 6 analog input, 6 PWM pins, and this is the feature of Atmega 328P. P means pico power. This microcontroller will run on low power. P means pico power, and high performance low power 8-bit microcontroller. So there is a 8-bit microcontroller, advanced reduced instruction set computer architecture. There are 32 8-bit general purpose registers. There are 3 8-bit input output ports. There are 32 KB flash memory, that we already 1 KB EEPROM, 2 KB SRAM, and there are on chip 10 to be ADC, and there are 16-bit timer also there. So this is the 28-pin IC, Atmega 328P. This is the 28-pin IC. Then there are 28 pin 1 to 14, then 15 to 28. And what is the meaning of digital or analog? So all physical quantities are analog, like temperature, humidity. These are the analog quantity. And digital means that quantity that take a specific value with specific offset between each other. Analog value, it can take any value between its minimum and maximum. Like digital, example of like English alphabet, there are 26 letters. So there is no letter between A and B. So that is digital. There are fixed level A, B, C, D. Between A and B, there is no any character. Like there is also square waves are digital. Then the second one is the analog signal. It can temperature, humidity. These are the analog signal, and sine waves are the analog. Square wave are the digital signal. So this is the detail of the Arduino UNO. So is there any doubt in this Arduino UNO? Everyone? Is there any doubt in this?
No doubt, sir.
Everything is clear? So what is the name of the microcontroller in this board? What is the name?
Atmega 328P.
Yes. And P means? What is the meaning of P means?
Low power.
Yes, pico power. P means that it can run on low power. So now, everyone, we will use this board. We will understand, we will do some hands-on on this board. So see here, everyone, you have to first understand the analog to digital converter. So anyone, do you know what is microcontroller? First tell me, what is microcontroller, what is microprocessor? Anyone? The microcontroller and microprocessor. What is difference in it? Anyone? Microprocessor and microcontroller. What is difference in it? Anyone, please unmute your mic and answer this question. Yes, please, participants, students, what is difference between microcontroller and microprocessor? Anyone? Any idea? Please unmute your mic and take interest. This is very important. Students, this is not college class. Don't take it time pass class. This class is very important for you. Please understand and please reply. Make session interactive. Anyone out of, so I think there are, how many students are there right now? So there are 90 students. So out of 90, no one knows what is microprocessor and what is microcontroller. Yes, students, anyone? You can speak by unmuting your mic. You can write into the chat. Yes, anyone? So see here, in the microprocessor, if there is a microprocessor, so there is only CPU. If there is a microprocessor, there is only CPU. Micro means small, processor means who process the data. So there is small, only processor, that is called microprocessor, when there is only CPU. So you have to add, you need RAM, you have to connect externally. You need flash memory, you have to connect externally. You need EEPROM. These are the memory you have to connect externally. Similarly, you need analog to digital converter. You have to connect externally. So every peripheral or memory you have to connect externally. So what is the problem in that? The size of the hardware is bigger. To solve this problem, the microcontroller will come. In microcontroller, there is all things into a chip. Okay, everything into a chip. So in this chip there is CPU, and also there is RAM, there is ROM, there is EEPROM, analog to digital converter, and remaining peripheral. All are the part of the IC like this. All are the like see here. This is the microcontroller. This one is the microcontroller. So in this IC, inside there is a CPU, there is RAM, there is ROM, there is EEPROM, ADC, DAC, UART, SPI, ITC, all peripheral into a single chip. So this is the microcontroller. And if we say the microprocessor like 8085 microprocessor kit. So see here in your college you will see this type of kit. So this is the microprocessor kit. See here, there are a lot of ICs are there. So these are peripheral ICs. So see the size of the hardware. This IC is much more powerful than this complete hardware. So which one you will use? This microcontroller you have to use, or this complete big wooden box? Which you want to use? This has less capability, this has more capability. Yes. Which one you choose? Microcontroller has lot of capability. It has much more powerful than complete hardware. So that's why everyone is working on microcontroller, because microcontroller there is a CPU, RAM, ROM already inbuilt into this IC, already inbuilt into there. No need to connect externally anything. So this is the microcontroller. The same type of microcontroller you will see into the Arduino. So into the Arduino, see here, this is the microcontroller, Atmega 328P. Is it clear to everyone? Yes or no?
Yes, sir.
So now, in every microcontroller, now understand. Like, this is the block diagram. I am making a big diagram for understanding. See here, imagine this is the microcontroller. So in microcontroller, there must be a CPU. In microcontroller, there is already a microprocessor. And there are some memory. The memory, like there is a RAM we needed. There is a flash memory we needed. There is EEPROM we needed. These are the RAM, flash, EEPROM. These are the memories. Memory. Now there are some peripherals. This is the analog to digital converter. There is UART. These are the peripherals. SPI. We have to understand every peripheral. SPI, I2C. There is timers. So these are called peripheral. What is called? These are called peripherals. These are called memories. These are memories. So RAM, flash, EEPROM, these are the memory, these are the peripherals. There are a lot, in every microcontroller there are peripherals. That's why in the website, in this website they are saying, see here, in the website they are saying, see here, UART, yes, I2C, yes, and SPI, yes. So these are three are the peripherals. PWM, this is the part of you can say the timers, and analog input, these are the part of ADC. This is the ADC. So right now we will study about the ADC. We will study about the ADC, analog to digital converter. Is it clear to everyone? Yes or no?
Yes, sir.
So
Yes,
we are studying the analog to digital converter. That are the peripheral of microcontroller. So see here, the ADC stands for analog to digital converter. This is the ADC symbol. Analog signal is a sinusoidal signal. It will convert into square wave signal. That is called the digital signal. So the analog value converted into digital. So see here, everyone, please understand this. Imagine there is a sensor. Imagine there is a sensor, and this is the temperature sensor. This is the sensor. There are temperature sensors. So it will sense the temperature from the environment. Yes or no? So inside this temperature sensor, there is a transducer. There is a transducer. What is transducer? There is a transducer inside the sensor. This is the temperature sensor. There is a transducer. What is the work of the transducer? Anyone? So see here, if you don't know, the transducer will convert non-electrical signal converted into electrical signal. Non-electrical signal is converted into electrical signal. So transducer is a device that converts non-electrical signal like temperature, humidity, pressure, like this, temperature or humidity, pressure. These are the non-electrical signals converted into electrical signal like voltage, current. So inside temperature sensor, there is a transducer who convert non-electrical signal into electrical signal. So non-electrical signal is temperature. So temperature is imaging converted into voltage. So the temperature sensor will give you voltage. Yes or no? It is clear, everyone? It is clear, everyone?
Yes, sir.
So in the so there is a sensor. I will show you. Just give me 1 minute. See here. So this is the sensor. The name of the sensor is TMP36. So this sensor can measure -40 degrees centigrade to +125 degrees centigrade range. Means if there is a -38 degrees centigrade, it will tell you, yes, the temperature is -38. Imagine if the temperature is -50 degrees, then it will not tell you because it is not in this range. So the range is -40 to +125 degrees centigrade. So there is a VS. This sensor we have to give input voltage like 3.3 volt or 5 volt. We have to give 5 volt, then ground. So it will give you V out. So temperature is converted into voltage. This V out means temperature is converted. So this is the physical structure. Temperature is converted into voltage. So who are converting temperature into voltage? What is the name of the device? Who are converting temperature into voltage?
Transducer.
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 So in every sensor there is transducer. Okay, it is clear everyone? It is clear everyone?
Yes, sir.
Okay, so everyone please open the Google. Everyone please open the Google. And in the Google write here the Tinkercad. Open right here and write in the Google write the Tinkercad. And there is a website www.tinkercad.com. Open this website, everyone. I will share the link of this. And please make account on this using your Gmail ID. Please make account on this using your Gmail ID. So make your account. Everyone just quickly sign up using your Gmail ID. So have you signed up? Please reply quickly. Do it quickly.
Yes, sir, done.
So have you signed in? So are you getting this type of page like this? Are you getting this type of page? Like it is your name and on the left hand side there are 3D design like this. Are you getting everyone?
Yes, sir.
So just
Yes,
click
sir.
on left hand side, just click on the circuits. On left hand side, just click on the circuits. Have you clicked? Have you clicked?
Yes.
Okay. So now click on the create new circuit, the green one. Create new circuit. Just click on the create new circuit. Have you done it, everyone? Have you done it?
Yes, sir. Yes.
So now in this is the online simulator. You can use it for Arduino UNO. You can make some of the Arduino circuits. You can program Arduino in this software. No need your hardware. If you don't have hardware, no worry. The Arduinos is available here. So see here in this, there are some categories in the basics. When you in component, there are two categories, basic and all. When you click on the basic, these are the some basic components. Some sensors are there. And when you click on the all, these are the all components that are available on this simulator. Similarly, there are some circuits. Starters means there are already some circuits. There are some basic circuits. See here, these are some basic circuits. When you click on the Arduino, these are some Arduino based circuits. When you click on the microbit, this is the microbit circuit. There are some circuit assemblies. So these are some pre-made circuit, we can say. So just click on this in this starter category, just click on the basic. In the basic, now see here, here are you getting the temperature sensor in left hand side? Are you getting the temperature sensor?
Yes, sir.
So just drag it and drop it here in this workspace. This area is called workspace. Just drag it and drop it. Okay, have you done it? Everyone?
Yes, sir.
So I already told about you in this sensor there are 3 pins. The first pin is the power pin that are connected with 3 volt. This is the 3 volt battery. Yes or no? So this is the 3 volt battery. The sensor has 3 pins: power, V output, and ground. So ground is connected with ground with black wire. With red wire, we are giving it 3 volt. So from this pin, what we will get? Yes. This is the V output we will get. So V output we are connecting with multimeter. So we are checking the voltage actually. Is it clear? This circuit is clear? Yes or no? Everyone?
Yes, sir.
Okay. Now on the right hand side there is a start simulation. So just click on the start simulation. Have you clicked? Have you clicked?
Yes, sir.
So see here, when you click on the sensor, you will get a bar. See here, I am just moving the sensor just to see you. See here. When I click on the sensor, so I am getting a temperature reading. See here. There is a bar. So this it is showing -40 degree to +120 degree centigrade. This is the slider. Everyone, are you getting the slider?
Yes, sir.
So see here, by this slider, you can change the temperature. So when temperature is changing, so temperature is converted. See here, temperature is the non-electrical signal. It is converted into the electrical signal by the transducer. So the electrical signal is voltage. Right now we are considering, and the non-electrical signal so temperature is converted into voltage by transducer inside the sensor situated. So the temperature is converted into voltage. So see here, you are at -40 degree centigrade, there are 99.9 millivolt, and 125 degree centigrade, there are 1.7 volt, 1.75 volt. It is clear? The sensor, temperature sensor, this sensor is an analog sensor. It will give you the analog value. The analog value is voltage. It is clear, everyone?
Yes.
Yes or no?
Yes, sir.
So please everyone see here. So I am repeating, I am telling again, our objective is not get the voltage. What is our objective? See here that there is a temperature sensor. This is the temperature sensor. The name of the sensor is TMP36. It is giving you the voltage because inside there is a transducer who are converting voltage. So imagine there is a temperature is, imagine 23 degree centigrade. So temperature is 23 degree centigrade right now, and we are getting the voltage 739 millivolt. Here the voltage is 739 millivolt. Yes or no? Yes.
Yes, sir.
So the temperature is 23 degree centigrade. At this temperature, the voltage what we will get, that is 739 millivolts. So this is the voltage. So now there is a microcontroller like Arduino. So in the microcontroller, there is a peripheral, that is ADC. This is the Arduino UNO. In the Arduino UNO, the microcontroller is Atmega 328P. So we are converting this, we are giving this voltage to the microcontroller. Imagine the pin are A0 pin, because these pins are analog pin, and this voltage is analog quantity. This voltage is analog. You can say, sir, temperature is also analog for non-electrical. We want analog signal, that is the voltage. So ADC will convert. We have to connect this sensor to the analog pin. We already discussed which are the analog pins. See here in the microcontroller, are the pin number A0 to A5. These are the analog pins. When any sensor will give you analog value, that you have to connect here. So the analog means voltage we are giving here. The voltage we are giving here, from voltage, this ADC, this this voltage into digital value. We have voltage, but our actual target is we want temperature. Yes or no? What we can do with the voltage? We want that temperature that is measured by the sensor. Yes or no? It is clear? So now voltage is converted into digital value by this ADC. This is the peripheral inside the microcontroller that will convert voltage into digital. From that digital value, we can get this temperature. So we can display that temperature onto the screen. It is clear to everyone? Yes or no?
Yes, sir.
Yes.
So I am making sequence here. See here, what there is a sensor. The sensor is getting 23 degrees centigrade and giving the output is voltage like 739 millivolt. So we are giving this voltage to ADC. ADC inside the microcontroller. ADC inside the microcontroller. So this ADC will give you digital value. What did give you? Digital value between 0 to 1023. The digital value you will get like 10, like 500, 600, 700 like this. You will get a value between this range 0 to 1023. So from this value you can get that same temperature that you measured by the sensor. The sensor, this is the TMP36. This is the sensor. Sensor sense the physical value. Physical value converted into voltage. Now voltage is given to ADC. ADC will converted into the digital value. From that digital value, we can get the temperature. This is our objective, to print the temperature. Yes or no, everyone? Yes or no, everyone? It is clear or not?
Yes, sir.
Any doubt? This is Arduino UNO. So in the Arduino UNO, there is a ADC. You have to connect on pin number A0. So you will get inside the microcontroller, there is a digital value. So by programming, we can get same temperature that the sensor measured. This is our objective, everyone. It is clear? Yes, is there any doubt? Please ask if you have any doubt. Anyone?
No
Right
doubt,
now,
sir. Understood.
understood? Okay.
No,
Thank you. If you have any doubt, please ask. I cannot cut your marks. Just make session interactive. So see here, the ADC convert voltage, ADC convert temperature into digital, or ADC will convert voltage into digital. Now tell me. ADC convert voltage into digital or temperature directly into digital. Which one is right? Which one is right? Temperature
Voltage
into digital?
digital.
Yes, voltage into digital.
Voltage.
Yes, voltage into digital. So see here, when we interface sensor to microcontroller, the sensor senses the physical quantity. Physical quantity means that we can feel. Can you feel the temperature or not? Can you? Yes or no? Your body will feel the temperature or not?
Yes.
Please reply.
Yes, sir.
So
Yes,
you
sir.
can, yes, that is the physical quantity. Humidity you can feel, speed you can feel, sound you can feel, pressure you can feel. These are the physical quantity. So the inside the sensor, so we need to convert these quantity into electrical signal. So physical quantity converted into electrical energy by a transducer. So in every microcontroller there is a transducer. If the in every sensor there is a transducer. But remember, the sensor should be then analog sensor. If the sensor is an analog sensor, it will give you analog value. That analog value is voltage. So the transducer converts physical data temperature into voltage. So the transducer converts a physical quantity into analog signal in the form of voltage or current. So many sensors have built-in transducer. The output of the most sensor is analog signal. So physical quantity converted to analog signal like voltage, current, resistance, capacitance, inductance. These are the you can say the analog quantity. So then ADC inside the microcontroller. Please remember, ADC not the outside the inside the microcontroller that converts this analog signal like voltage to digital signal so that it can be processed by the microcontroller. Because microcontroller understand only digital, like you understand right now only English or Hindi or your mother tongue. You cannot understand the French. So similarly, microcontroller need is digital signal. So that's why we are giving microcontroller the digital signal, and then we can process the digital signal, then we can get the same temperature. It is clear, everyone? Yes or no?
Yes, sir.
So now our topic is, now you can answer what is our topic. So see here, our topic is, there is microcontroller. This is microcontroller. Inside the microcontroller, there is ADC. So our topic is how the ADC convert voltage into digital. Our topic is this, ADC, analog to digital converter. How the voltage is converted into digital. It is clear, everyone?
Yes, sir.
So the analog signal is any continuous signal. What is the meaning of analog signal? Like voltage, current. Analog signal is a continuous signal for which time varying feature of the signal is representation of some other time varying quantity. Like when time is changing, the voltage is changing. So it is analogous to another time varying signal. So voltage, current, these are the analog signals. Digital signal, that is the output of the ADC. The digital signal is signal that being used to represent data as a sequence of discrete value. So the sequence is 0 to 1, 0 to 3. At any given time, it can take only one value, one finite number of value. So digital signal, like you will get the value between 0 to 1. So you can answer why you are getting value between 0 to 1, 0 to 3. So see here, everyone, our topic is ADC. Now I think you understood. So imagine, everyone, this part is very important. So imagine this is the sensor. The sensor is TMP36. So imagine this is the sensor and this is the range of the sensor. Sensor will give you minimum voltage 0 volt and the sensor will give you the maximum voltage at 5 volts. So this is the V out pin of the sensor. It will give you the minimum voltage 0 volt and the maximum voltage 5 volt. So now this is the, here we can make the ADC. This is the ADC, analog to digital converter inside the microcontroller. So when we will give 0 volt to ADC, so what is the value given by ADC, digital value? Imagine the value ADC will give you 0. So 0 volt is converted into digital, that is 0. So imagine the sensor, the maximum voltage given by the sensor is 5 volt. So what is the maximum value then given by the ADC? When you will give 5 volt to the ADC, what is the maximum value you will get? So that value is decided by a factor. That factor is called the resolution of the ADC. So the resolution of the ADC is the number of the bit it uses to digitize the input samples. Means if the in this microcontroller in Arduino UNO, the ADC has 10-bit resolution. Means you will get the maximum value, that is 2 to the power 10. 10 means this is the resolution. And what is the meaning of that? What is the meaning of that? The resolution of the ADC is the number of the bit it used to digitize the input sample. Means imagine there are scale. Imagine this is a scale. So this is the 0, 1, 2, 3. So similarly, how many cuts on this? So the cuts, these are the dots. How many dots? So the maximum dot number is 1, 0, 2, 3. Because you can say, sir, 2 to the power 10 is 1024, but we are starting from 0. So 2 to the power 10 minus 1. So the maximum number is 1023. So there are 1024 lines. Means there are 1024 sections. Is it clear, everyone?
Yes, sir.
So ADC will give you the digital data between 0 to 1023. Between 0 to 1023. Please remember, because this ADC is 10-bit ADC. You cannot change the resolution. It is fixed by the manufacturer. This is fixed. The resolution of this ADC is 10-bit. It is clear, everyone?
Yes, sir.
Yes.
Okay. So this is the resolution. See here, the resolution of the ADC is the number of the bit is used to digitize the input sample. For the n-bit ADC, the number of discrete signals level can be produced in 2 to the power n. N means number of steps. So there are, this is called one, like this is called one step. Like I will make it, choose another. This is called one step, 2 step, 3 step. So how many steps are there? How many steps are there? 2 to the power 10 steps. It is clear, everyone?
Yes.
Then there is the throughput rate. Throughput rate or data rate ADC refer to the amount of time that it takes to complete a whole conversion. A whole conversion includes the time that it takes to set up, sample, convert, and transmit the data. So there are some comparison analog and digital signal. So now see here. The 0 volt is converted into 0, 5 volt is converted into 1023. So if there is 2.5 volt, we will get the mid value, because here is the mid value. This is the mid value, that is 2.5 volt. So similarly, we can get here that value. That value is 512. It is clear. The 0 volt converted into digital, that is 0. 5 volt converted into digital, that is 1023. It means 2.5 volt is maybe 511 or 512. It is clear, everyone? Yes or no?
Yes, sir.
So similarly, on the left hand side, there we have to calculate the step, this size of the step. Yes or no? So similarly, there are on the right hand side, there are 1024 steps. Maybe means there we have also calculated the 1024 steps. Yes or no?
Yes.
So how to calculate the step? What is the maximum value? 5 volt. How many steps we required? 1024. So we will get the value 4.88 millivolt. So this value, when there is 4.88 millivolt, so that when you convert into digital, you will get the 1. It is clear, everyone? Yes or no?
Yes, sir.
Similarly, what is the value when you will get the 2? What is the value on the digital? In the analog? This step size is 4.88 millivolt, because we have to also divide this scale into 1024 parts. So one part value is 4.88 millivolt. So what is the value of voltage when you will get here the 2? What is the value of voltage then? What is the next value? The gap between this is 4.88 millivolt. What is the value then? Then 9.76 millivolt. Yes or no? Yes or no?
Yes, sir.
So similarly, what is the next value? what is it? So 9.76 millivolt plus 4.88 millivolt. So you will get the next value. Then you will get the 3 here. Yes or no, everyone?
Yes, sir.
So this is called the step size that you are calculating here. 5 volt divided by 1024. This is called the step size. See here the formula here. This is simple mathematics. See here the step size. When sensor will give you 0 to 5 volt. So you will get the maximum value 5 divided by 1024, the 4.88 millivolt. So you have to check only the first row. So what is the value is there? 4.88 millivolt. It is clear, everyone? Yes or no?
Yes.
This is the ADC. You are actually you are reading on the ADC. This is the analog to digital converter. So this is the ADC. So how can you get the digital output? Imagine there is a question like that. See here, I have to remove this. See. So I will make here the new. So when there is 0 volt, you will get digital 0. When there is 4.88 millivolt, you will get here 1. When there is 9.76 millivolt, you will get 2. When there is 5 volt, plus when you are doing, and 5 volt means 5000 millivolt, you will get here the value that is 1023. Is it clear, everyone? Yes or no?
Yes, sir.
So my question
Yes, sir.
is, if there is 3 volt, 3 volt means 3000 volt. 3000 millivolt. Then what is the value in digital then? How can you calculate? The one step size, this step size is fixed, that is 4.88 millivolt. Imagine there is a 3 volt. How can you calculate then what is the value? So we can do this 3 volt divided by 4.88 millivolt. Yes or no? Yes or no? Please tell me.
Yes, sir.
This is simple mathematics, yeah. See here, if there is a 1, 2, 3, 4, up to 10. Okay. So, and here also, and here is, imagine there is a 5. Okay. And here 1 means 1, 5 means 2, 10 means 3. Okay. Imagine. So if there is a 5, how can you calculate the answer in this? 1 means, so how many step size? There is 1 step size, 1 step size, 1 step size. This is the 1 step size. So how many parts are there? There are 5 parts. So this is the 5th part. Similarly, this is the 3 volt. What is the value of minimum 1 part? So there are 4.88 millivolt. So if you divide this, so you can get the number of the line. Yes or no? So when you divide 3 volt divided by 4.88 millivolt, so you will get the answer. Similarly, how to calculate the digital data? See here, how to calculate the digital output. D out means digital output. V in means 3 volt. 3 volt divided by 4.88 millivolt. You will get digital data. It is clear, everyone? Yes or no?
Yes, sir. Yes,
This
sir.
is simple mathematics. Here you can check. So how many step size? The step size is 1, 2. So you have to measure the same. In this case, when you when you check here this part, So see here, you are counting. You are saying here 0 volt. See here, you are seeing here 0 millivolt or 0 volt, or both are same. 0 millivolt and 0 volt. So you are getting the 0. Next, 4.8 millivolt. Please count 1. Now next, then you can add 4.88 millivolt. You will get the next. So 9.76. Then count 2. Then add plus 4.88 millivolt. You will get the next value. Similarly, when there is a 3 volt. So actually you are counting na, this how many? This is 1, this is 2, this is 3. Yes or no? You are counting how many steps. So that's why you have to, in 3 volt, how many steps? So 3 volt divided by 1 step value. So you will get how many steps. Is it clear, everyone? Like,
Yes, sir.
like there are 500
Yes, sir.
rupees and you have to count how many 5 rupees coin. So what is the minimum value of 1 step? 1 step is 5 rupees. So there are 100 coins. Yes or no? So this is the maximum value,
Yes,
and
sir.
this is the one step value. So similarly, the maximum value is anyone. This can be 0 to 5 volt, anyone. So please tell me if the maximum, if the I will give you 3.7 volt. If there is a 3.7 volt, now tell me what is the value into digital. Everyone, please calculate it. You can use calculator. 3.7 volt. If there is a analog value, so in the digital, what is the output? And the step size is 4.88 millivolt. Now tell me. Now tell me. What is the value? Yes. Hello. Your voice is breaking. Please, you can write into the chat. What is the value? Answer then. Yes. Participant, please reply. V in is 3.7 volt divided by 4.88 millivolt. 3.7 volt divided by 4.88 millivolt. What is the value then? Divide by 4.8 millivolt. So you can calculate using this formula. We have less time. So this is in the ADC. There are onboard ADC channel which can be used to read analog signal in the range of 0 to 5 volt. So it has 10 bit ADC, means it will give you temperature in the value between 1023. So this is a TMP36 sensor. There is 0.5 volt offset value. So you have to subtract that 0.5 volt. So how to connect this? So see here in the Tinkercad, we can print the temperature. So I will show you. You have to understand some. We are making right now. So see here, I have already pre-made circuit. See here. This is everybody. Are you able to see? Yes or no? Everyone?
Yes, sir.
So see here, this is the TMP36 sensor. This pin is connected to 5 volt, this pin is connected to ground, and this pin is connected, yellow one is connected to pin number A0. So by writing the code, I am writing the code here. So there is a sensor pin, pin number A0. This is the Arduino programming. See here. And Arduino pin is input pin. This sensor pin is pin number A0 is input pin. Serial dot begin. We are printing the temperature on serial monitor. So this is the analog read pin. This will give you the digital value. From digital value, you have right now digital value. See here in this formula. you have digital value between 1, 0, 2, 3. So if you multiply this digital value with step size, you will get the V in. You will get the temp voltage that is given by the sensor. So see here, you will get here the voltage. Now we have to subtract 0.5 volts. This is the offset value of this sensor. Then in this sensor, it is written here. So 10 millivolt is equal to 1 degree centigrade. When you say the 10 millivolt, it means 1 degree centigrade. So we have to divide the voltage divided by 0.01. That is 10 millivolts. So we will get the temperature. So I will print the temperature on serial monitor. When I start the simulation, see on the serial monitor. See here, I am temperature I am printing here. So see here, when I click on this sensor, when I am changing temperature, the maximum temperature, see here, 140, 125. So see here, their temperature is 125. So by programming, I am able to print the same temperature that are given by the sensor. See here, the in minus reading. See here, I am able to print the temperature. So this is the perception layer. Sensor interfacing with microcontroller. Now you have the data. It is clear, everyone? It is clear, everyone? Yes or no?
Yes, sir.
Yes, sir.
So see here, you have to understand this programming, how I am doing. You have to understand. In this workshop, we are only demonstrating how we are calculating. So see here, the temperature is giving you voltage. By voltage, by programming, you are the ADC giving us the digital value, the reading. By reading, by programming, see here why I am getting the same temperature that are given by the. So when you change the temperature, here also the temperature is changed. So you will able to print the temperature. Similarly, humidity, pressure, any analog value. So you have to choose the right one sensor. You have to choose the right sensor, appropriate sensor. Then you can measure the physical quantity and print. And you can also print on LCD, and you can print on the OLED display. Anyone. You can send this data to cloud also. It is clear or not, everyone? Is there any doubt? You can ask. Anyone? Is there any doubt in this? Without hardware, we are doing the Arduino programming using this software. Yes. Is there any doubt? You can ask. Anyone? Anyone? Is there any doubt? It is clear or not? Still any doubt? Please reply, student. This is your future.
Clear, sir.
Please thankful to the college who are organizing this type of workshop. And you are, if you are saying, if you are saying by doing this, printing this temperature, you will get the job. You never get the job. You have to do a lot of work. If you open the Google and open the Naukri.com, see here everyone, open the Google and open the Naukri.com and see here everyone, see here the skill. Skill is IoT engineer. See here, the skill is IoT engineer. See what the industry demands. IoT engineer, these are some companies. Now you are all are fresher. Okay. So I will check the. Just give me 1 minute. So say this is the, see there is a job between 0 to 3 lakhs because you are. So see here the IoT engineer in Snap Hunt company. Okay. It is, and job in Hyderabad. See the skill what they are demanding. See here, well deserved with multiple. You have to understand embedded C, embedded C++. You have to understand Python, Arduino. See here, and the big data and machine learning algorithm you want. Proficient knowledge of the sensor, in-depth understanding of computer programming and network security. This is the job for between 0 to 3 lakhs. See here. Also, support engineer IoT. This is the trainee engineer. Check what the industry are asking. So see here, the IoT involve working on hardware, microcontrollers, sensors, and software. Working in the field of embedded system. So you have to be master on embedded system also. See here, the support engineer job. See what industry demands. See here, the support engineer include continuous monitoring of end-to-end life of the dev, IoT product monitoring improvement. So you have to check the technical skills. See here, embedded system and engineer, IoT application and analytics. See here the null job description. That is in short, people say JD. So see here, 0 to 2 years experience in the field of embedded C. You have to understand C language. Hands-on on PIC, AVR, ST microcontroller, ARM Cortex microcontroller, SPI, I2C, UART, DMA, timer, interrupt, work with peripheral. See here, these are the skills for embedded and IoT engineers. So please check everyone what industry demands and what you know. This is the HCL Japan. And see here, soft IoT test engineer, IoT developer, electronics engineer. What the industry demands, that is more important. Knowledge of electronic circuit, Arduino, ESP, and other microcontrollers. Is it clear, everyone? Yes or no?
Yes,
Everyone? So please upgrade your knowledge. You need the college, what you have to study, in the college what you are studying, but you have additional trainings also. So please update yourself. You are in industry. See here. In college you have this knowledge. In industry, the requirement of this knowledge. So there is a gap between college and industry. You have to fill this gap. In industry, there are a lot of skills that are not in your syllabus, in college syllabus. So you have to update that skill by the training. You have to do trainings that are more important. When anyone join army, there is a army training. When anyone join IAS, become IAS, there is a training into the Masuri. They give training. Similarly, you are becoming an engineer. You need training. You have to understand different language. C language, C++, Java, Python. You have to work on Arduino, Node MCU, ESP32, Raspberry Pi. You have to do the cloud computing also, how to upload data on different cloud, IoT protocols. You have to get this knowledge. This is not in your college syllabus. You have to read, you have to study about from outside. You have to do training. So please remember this thing. Is it clear, everyone? Yes or no?
Yes.
yes, sir.
This is the first part of this session. You are printing the temperature onto the. So now in the next part, that is the node MCU. That is one of the IoT hardware that we will use. See here, this is the node MCU. It has Wi-Fi capability and it has also the microcontroller. The microcontroller is 32-bit microcontroller. This small module is much more powerful than Arduino UNO. So this is the ESP8266 chip, ESP8266 version. So see here, the IoT applications are on the rise and connecting objects are getting more and more important. So there are several ways to connect objects such as Wi-Fi protocol. So Node MCU is an open source platform based on ESP8266 which can connect objects and let data transfer using the Wi-Fi protocol. So in addition, by providing some of the most important features of microcontroller such as GPIO, PWM, ADC, it can solve many of the project's need alone. So the general feature of this board, you can program this board with Arduino IDE. It is available as an access point. It is a practicable in event-driven application. It is having an internal antenna, and there are 17 GPIO, 4 PWM. So there are 17 GPIO, 4 PWM, I2C, SPI, and ADC UART. So this part, please see here, when my cursor is moving, this part is soldered onto the chip. So this chip is called ESP8266. See here, this chip part only. Where my cursor is moving, see here, this part, that are soldered onto this board. This chip is ESP8266. So most people call ESP8266 as a Wi-Fi module, but it is actually a microcontroller. ESP8266 is the name of the microcontroller developed by Espressif System, which is a company based out of Shanghai. So this microcontroller has the ability to perform Wi-Fi related activity, hence it is widely used as a Wi-Fi module. So there are many types of ESP8266 modules, ESP01, ESP02, 03, 04. So right now in this module, in this node MCU, there is ESP12E module. ESP12E module it is using right now. So this is the ESP12E chip pinout. ESP12E is soldered onto this board. Complete board is called node MCU, and this chip is ESP12E. Is it clear, everyone? What is the name of the chip?
ESP.
ESP12E. Okay. And what is the name of complete board?
Node MCU.
Node MCU, yes. And in this chip, there is a microcontroller. So what is the name of the microcontroller? ESP8266. ESP8266. Okay. So this is the ESP12E module. Like this, I will show you. This is not available into the Tinkercad. For IoT work, here for IoT, you need hardware. So this is the ESP8266, this one. This is ESP8266. All are, this is the ESP8266. So the development board, the complete board is called Node MCU, equips the ESP12E chip module containing ESP8266 chip, having Tensilica extensor 32 bits LX106 microprocessor. This is the name of the microprocessor, and it operates on 80 to 160 megahertz. The speed of the Arduino UNO is only 16 megahertz, and the speed of this is 80 to 160 megahertz. There are 128 KB internal RAM, 4 MB flash. There is only 2 KB RAM. Here is 128 KB RAM. The flash is 4 MB here. There is a flash only 32 KB, and there is a 2.4 gigahertz antenna is also there for Wi-Fi work. Okay. So there is a Wi-Fi transceiver IC, that is the ST40. It interacts with the internet, but it can also set up a network of its own. It can set up your own network. It can allow other devices to connect it directly. The power requirement, there is a operating voltage is 2.5 volt to 3.6 volts. There is a 6 milliampere regulator current, and also this is the LDO 3.3 volt. This is 3.3 volt board, not 5 volt tolerant board. The Arduino UNO is 5 volt tolerant board. This board is 3 volt tolerant, and there is a low dropout. This is the voltage regulator there, and the output of the voltage regulator is also broken out one of the sides of the board and labeled 3 volt. So you will get the pin 3V3, 3V3, 3V3. From these pins you will get 3.3 volt. Okay. So power to ESP82, how to power it? You can power it with micro USB connector. So there is a micro USB connector. You can power it with this. Okay. So there are some peripheral ADC, UART, PWM, I2S also there. There are reset button, flash button. There is a onboard LEDs also there. For serial communication, you will get the CP2102 IC. How to program it with? This is the pin configuration. Like D0, D1, D2, D3, D4. This is the pin configuration. D5, D6. Some pin are 3.3 volt ground. Here is also 3.3 volt ground. So this is the total 22 pin ICs are there, and out of there are 30 pin are there. On this board there are 30 pins, and on this chip there are 22 pins. Is it clear, everyone? This is the node MCU. Why we are using? Because it has Wi-Fi capability and it can easily connect it to the Wi-Fi. Second, it is much more powerful than Arduino UNO, and there is a 32-bit microcontroller, and the price is, compared to price, it is very cheap with respect to Arduino UNO and the Wi-Fi shield. It is clear, everyone? Yes or no? Clear, everyone?
Yes, sir.
Yes, sir.
So everyone open the Arduino website. Please, everyone quickly open the Arduino website, arduino.cc. So have you opened the Arduino website? Everyone? Have you opened? Please reply. Have you opened the Arduino website? Please reply quickly. I am not getting any reply. If someone is replying, the voice is breaking. Please reply quickly. Have you opened the Arduino website?
Yes, sir.
Yes, sir.
Then click on the software. Click on the software. Now, click on this first one. If you have Windows operating system, then click on Windows Win 7 and newer. Just click on Windows Win 7 and newer. Like this. So are you getting like this? Yes or no? Are you getting like this? Everyone? Are you
Yes,
getting
sir.
like? Now click
Yes,
on
sir.
now click on just download and download the Arduino IDE. Just click on just download and download the Arduino IDE quickly. Just click on just download. Then you have to download the Arduino IDE. So the downloading is started or not?
Started, sir.
Okay. Please download it and install it quickly. Please download it and give me 1 minute. Just please download it and install it. Everyone, the downloading is started or not? The downloading is started or not? Please reply quickly.
Yes, sir.
So please download it and install it. Everyone. So have you downloaded? So have you downloaded? Have you downloaded or not? Please, student, reply. I am asking again and again. Only 2 and 3 student is replying. Hello.
Sir, downloaded.
Okay, install it then. You will get a .exe file. Please install it by simple double click over their .exe file and install it. So have you installed it, everyone? Have you installed it?
Yes, sir.
Okay, now open the Arduino IDE. You will get a shortcut onto the screen. Just double click on this Arduino IDE. Just double click over there. Just double click over there. And the Arduino IDE is opened. The Arduino IDE is opened or not?
Yes, sir, it's open.
Okay, now follow the steps. Please, everyone. Now follow the steps. We have to ISTE8266 setup using Arduino IDE. Means when you download the Arduino IDE, so by that Arduino IDE, you can program only Arduino UNO board. But right now we want to program Node MCU using Arduino IDE. So we have to make some changes in Arduino IDE. So that is the integration of Node MCU into Arduino IDE. We can say that. So how to integrate Node MCU with Arduino IDE? So when you open the Arduino IDE, so just see here, go to File on the left hand side. See here, there is a File. Then click on the Preferences. First click on File, then click on Preferences. Have you done it, everyone? See here, I am also doing with you. Click on File, then click on Preferences. Is it okay? Have you done it?
Yes, sir, done.
Now, are you getting here the additional board manager URL? Here, where my cursor is moving. See here, additional board manager URL. Are you getting? Yes or no? Here, are you getting this line, additional board manager URL, and here is the
Yes,
blank.
sir.
Okay, so just give me 1 minute. I am sending a link to you. So please copy that link and paste it here. I am sending into the chat. So just don't open this link, just only copy that link. Only copy that link and see here, paste it here, additional board manager URL. Have you pasted? I sent the link through the chat. I sent the link through the chat.
Yes, sir, it's pasted.
Pasted, then click on the OK. just click on the OK here. Have you done it, everyone? Have you
Yes,
done it? Now click on the tools. I will show you in the this, then you can easily. Then click on the tools. Here is the board, Arduino UNO you will get. Then click on the boards manager. First click on tools, board manager. Just click on the board manager. So the board manager will open. You have to wait here one minute. It will open. So the board manager will open or not?
yes, sir. It's open.
So now in the search, write here ESP8266. In search, write here ESP8266. So you will get this ESP8266 by ESP826 community. Are you getting? I'm also doing with you. This is the board manager. You have to wait because see here the downloading platform index. We have to wait. Now here you have to write ESP8266. So are you getting this? Yes or no? Everyone.
Yes, sir.
So now here just choose the version 3.0.2 and click on install. Then click on install. Then click on install. So now the downloading is started. Now the downloading is started. So downloading is started or not?
Sir, done downloading.
Okay. So it is showing like this ESP826 community version 3.02 installed. It is showing like that.
Yes, sir.
Then close it. Then close it. Now again in the Arduino ID, go to tools, board. Then here you will get ESP8266 board. So just select this Node MCU 1.0 ESP12E module. Are you getting? Are you getting? Yes or no?
Yes, sir.
So just select this. It is clear, everyone? It is clear, everyone?
Yes, sir.
Many students are waiting for 12 p.m. because they are only mute. So who is replying? What is your name?
Sir Gaurav.
Gaurav. Okay. What about remaining participants? So Gaurav, is there any doubt?
No doubt, sir, as such.
It is clear? The ADC, the Arduino and this Node MCU?
Yes, sir. All clear.
So except Gaurav, can you write into the chat why we are using Node MCU? Any one reason why we are using Node MCU? Why we are not using Arduino UNO? Anyone except Gaurav, can you write into the chat why we are using Node MCU? Yes, participant. Anyone? It has Wi-Fi capability. Okay. 32-bit microcontroller. Okay. Because Node MCU has Wi-Fi capability. Okay. Remaining participant? Yes. And the biggest, we can use Wi-Fi capability more powerful than Arduino. Yes. Aryan also, you are right. Rohan, we can use Wi-Fi capability. Yes. Sakshi saying it has Wi-Fi capability, 32-bit microcontroller. Yes. Any other? And the price. When if you want to use the Arduino UNO, you have to purchase two hardware, Arduino UNO and the Wi-Fi shield. Do you know this thing, na? Yes or no? Gaurav,
Yes, sir. Yes.
if you want to use Arduino UNO or any Arduino board, you have to purchase the shield. But in this Node MCU, no need to purchase the shield. So anyone have you worked on this Node MCU? Gaurav, you?
No, sir. Actually, I have worked on Arduino UNO.
Arduino UNO. So you have not done any work on IoT related projects.
So actually, I'm doing right now on IoT. It's in progress.
Okay. So right now, anyone, do you have the Node MCU board? Gaurav, you have?
No, sir. At present, I don't have it available right now.
Okay, okay. Okay, so everyone, so now hello, am I audible? Hello.
Yes, sir. You're audible.
Yes.
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 So there is a connection break. Okay. So now are you able to see the screen, everyone?
Yes, sir.
So now see here in the tools, the board is this. I connected the board. So see here, I connected the board at form 3. When you have hardware, you will get this. Okay. So now I will turn off and on LED. So there is some example code, the blink code. So see here, this is the code. This is the turn on and off LED. So there is a tools in the board, and this is the port. Now I uploading this code. So by pressing this button, now I am uploading the code onto my board. So see here, the sketch, the code is written is called sketch in Arduino programming language. So the code is compiling. So this is the hardware. I will show you through webcam. Just give me 1 minute. So everyone, are you able to see the hardware? Hello? Everyone, are you able to see the hardware?
No, sir, it's not visible.
Now you able to see the hardware?
Yes,
Yes, sir,
sir.
it's visible.
Yes,
So
sir.
see here, this is the hardware that I am using right now. So this is the node MCU is connected. See here, this is the node MCU is connected. And there are some sensors that we shown. This is our board. Right now I am using this. So still the code is compiling. Let me check the code. So see here, the LED is blinking. Are you able to see? Everyone? See here,
No,
the
sir.
LED is blinking. Now, see here.
Yes, sir.
So this LED is blinking. So we can connect different sensors. See here that this is the different sensor. And I will show you one more code. Just give me 1 minute. Just give me 1 minute. It will take some time then. Just so we can print the temperature and humidity reading onto the screen. Just give me 1 or 2 minutes because I have to do some connection also. So will take some time. Let me. So, is there any doubt you can ask anyone? If you have any doubt, you can ask anyone, any student in this. Do you have any doubt? Yes, student. Do you have any doubt?
No doubt, sir.
Just give me 1
No,
minute.
sir.
I am connecting the sensor, connecting the OLED display also. So it will take some time. Just give me one. Just give me 1 minute more. This is the code is still compiling. I am uploading the code. I connected the OLED and DST one. This is a sensor that is a temperature and humidity sensor. I connected. Now we will print temperature and humidity in OLED display. So just it will take some time to upload the code, and we have to check the connection also. So still, is there any doubt you can ask, students? Any doubt you can ask? So please guys, you have to work on this type of hardware. You need hardware. The IoT work you cannot do onto the simulator like Tinkercad or any other. You need hardware. So anyone, if you are interested to purchase this board, you can purchase this board. You can contact me. We will ship the board if anyone interested. So I will also show you the different projects also. So in our 31st March lecture, there is 10 to 12. There we will do some hands-on. Then we will control the home appliance using our mobile app. So that is also interesting. So now code is still compiling. It will take some time. You see here the code is compiling. Is there any doubt, anyone? Now code is uploading. We have to check the wire. If the temperature is not printed, then we have to check the connection also. So see here everyone. So see here I connected a DST11 sensor. Are you able to see the temperature humidity printed onto the OLED display? Yes or no? Everyone.
Yes, sir.
So see here, this is the connection. I am using this DST11 sensor, that is the temperature humidity sensor, and this is how you connect the sensor to this board by using these wires. See here, by using these wires you can connect. So see here, right now I am printing the temperature and humidity onto this board. So this is the weather monitoring system you can make in couple of minutes. So sensor is connected at pin number D4, and these are the pin for OLED display. These 4 pins, see here, these are the 4 pins that are for OLED display. So this is the temperature and humidity you are printing. Is it clear, everyone? How to? So there are a lot of sensors. This is the ultrasonic sensor. This one is the MQ135 sensor, that is air quality sensor. There are LDR sensor, temperature, humidity. There are some LEDs also, and push button are also there to give input. OLED display. This is the MPU 6050. This is the gyroscope and accelerometer. Is it clear, everyone?
Yes,
See
sir.
here, these are
Yes, sir.
the some pins. Is it clear, everyone?
Yes, sir.
So this type of hardware you can use. See here how I program. So by writing the program, you can upload the code and you can use this board. It is clear, everyone? So this
Yes,
is the
sir.
Arduino. On Arduino, you can work on the Tinkercad, and for Node MCU, you have hardware like this. So if anyone interested in hardware, so you can check the hardware here, and you can also contact me if you need this type of hardware. See here, this is our website. I will share this website with you, and you can check the hardware. So this is the future actually. Everyone, please understand. You have to use hardware, different hardware. See here. This is the IoT development board right now we are using. So if you are interested to purchase this board, we will ship this board on the fixed amount. That amount is 1500. So we are reducing your amount. You no need to pay this amount. You have to pay only amount 1500. So you can contact me through the this Telegram group, or you can also WhatsApp me. You can contact the Shubhangi ma'am, then she will give you my number. And there is also some IoT hardware. We will give you this board at 1500. There is no shipping charge. And also there are a lot of hardware also there. See here, this is the ESP32 with LoRa communication. This is the ESP32 board. And also one board for this is the LoRa. These are some costlier boards, but you can explore it, you can understand it. See here, there is Arduino. This is the Arduino. There is the LCD, same temperature, humidity, air quality sensor, relays is also there, and motor driver is also there, MPU 6050, LCD. This is the one thing, that is the LoRa module is also there. So these are type of hardware. Right now in this workshop, we are using this. We also provide training in the field of embedded IoT machine learning. So if you are interested in training, you can also contact on this, and you can also contact on this the IoT Academy. This is the IoT Academy website. I will give you the IoT Academy. This is the IoT Academy website. You can check here the online courses or offline courses. You can check here. So I will also give you this website. You can check the courses also there. Is there any doubt? You can contact me. But students, check. You have to do some training also. You have to understand what is the gap between industry and the college curriculum. You have to fill that gap by the training. So this is the end from my side, Shubhangi ma'am. This is end from my side. Hello. Hello ma'am, are you there?
Can you hear me?
Well, your voice is breaking.
English.
Your voice is breaking, ma'am.
Now can you hear me?
Yes, sir.
Student, I think stop here. Yes.
Your voice is breaking, ma'am.
Yes. Any questions? If you have any query, you can ask. If you don't have any query, we'll stop here and we'll meet tomorrow. Am I clear, students? Tell me if you have any query, you can ask. So, unmute your device and tell us. Or you can write in chat box also. Yes, Mansi? Mansi Dubey?
Yes, ma'am. Hello.
Do you have query? Do you have any query?
No, ma'am.
Okay. Message in chat box, no queries. Okay. So we'll wait, we'll stop here and tomorrow morning we'll meet at 10 a.m. Thank you, sir.
Ma'am, no,
Thank you, Jitesh,
not
sir.
tomorrow, ma'am, not tomorrow, 31st.
Yes, 31st. Yes. All 31st students. There is no session. The day 3 session is scheduled on 31st March. Remember this? 31st March, join the session at sharp 10. Is that clear, students? The
Yes,
session is
ma'am.
scheduled on March. Yes, good. Here, any query? Contact me. I'll give you Jitesh's number related to her. Okay, and to contact Jitesh. And you can fill the Jitesh sir is there on Telegram. Okay, so to discuss about hardware for IoT, they can put a message on our Telegram group. Yes, so we'll stop here. Students, thank you, sir. Bye, sir.
Thank you, ma'am. Thank you, ma'am.